Hello students, I am Partha Chakraborty from Department of Geology, University of Delhi. Today our topic of discussion is Indian sedimentary basins with a little thrust on their hydrocarbon prospect. Now, once you go through this discussion, I hope you will be able to know that what is the total basin volume of sedimentary basins in Indian peninsula. We also will be able to know that how they are categorized in terms of their prospectivity of hydrocarbon content. We will be discussing with a few examples that what really is mean when we talk about a petroleum system in a sedimentary basin, and some of the category 1 basins such as Assam, the Bengal basin, the category 2, and some these basins will be discussed, so that you can understand that how really we take note of that how these sedimentary basins that evolve and help us to understand its hydrocarbon prospect. Now, in India peninsula, the total areal extent of the sedimentary basins both on land and offshore up to 200 meter isobath, that is about 1.79 million square kilometer. We normally take this up to the 200 meter isobath. Beyond the 200 meter isobath in the deep water, there is another 1.35 million square kilometer is the total basinal area in the Indian crater. So, together they make about 3.14 million square kilometer area, the sedimentary basins that cover the Indian cratonic part. Now, how these basins are basically looked into, and what are the total number of basins? Nearly 26 major sedimentary basins that has been delineated, and they are categorized by Director General of Hydrocarbon into 4 different categories, that is category 1, category 2, category 3 and category 4. Now, category 1 basins are which are most prospective and which are already yielding hydrocarbon. So, it has been prospected and explored and it is yielding hydrocarbon. Now, these basins include the basins like Assam Shelf, then the Kaveri, then Krishna, Godavari, all these basins, they Bombay High, all these basins they are categorized as the category 1. Then those basins which has a high prospect we know, but we do not yet gone for the proper exploitation of those basins, they are the category 2 basins. Now, in the category 2 basins we get the Andaman Nicobar, the Himalayan foothill, the Bengal basin, you get the Kutch, the Jaisalmer, all these basins, Mahanadi, all these basins they are categorized as the category 2. Category 3 basins, that it shows all the geological feature that it should be prospective, but it is yet to be prospected. Then we call it a category 3 basins, and these category 3 basins in India, they are categorized as the Bikaner Nagaur basin, the Lakshadweep basin, and all these basins they are basically the category 3 and category 4, that at the present state of knowledge it is considered to be least prospective, but with the proper and the advanced technology and the more study, there is a scope that it can be identified in future. So, the studies is needed, more studies needed in these basins, that we call the category 4 basins. So, once we categorize all the 4 types of basins, then our aim is to identify that how really we consider these basins, that how the different kind of hydrocarbon prospect which needs to be searched into in all these basins. So, now we will take forward our discussion with discussion of some petroliferous basins of India. The one of the major petroliferous basin, that is the Assam Basin, which is situated in the northeastern part of India and categorized as category 1 basin. It covers an area of 11,600 square kilometer. Major tectonic elements are the Assam Shelf, Naga Supen Belt, Assam Arakan Fold Belt. The oil exploration, it started in this basin with discovery of the Digboy oil field, and then the other oil fields, that is Naharkatia, Moran, Rudrasagar, Lakwa, these were discovered. The basin covers the states of Meghalaya and Assam. The upper Assam basin, that consists of northern Himalayan foreland basin and the southeastern Assam Arakan foreland basin. The Assam Arakan foreland basin consists of thick wedge of pre-orogenic massive margin Cretaceous Eocene, that is Khasi Jayantia group, the deep marine Oligocene Beryl group, fleece sediment, and that is overlain by post-orogenic Neogene Molasse, that is the Tipom group. The Paleocene to Eocene continental shelf of the Indian plate that become emergent and is being overthrust by the Himalayas on the northwest and by the Naga hills on the southeast comes under the upper Assam shelf. The present day Assam basin, a cratonic margin, reflects three distinct tectonic phases. The earliest was late Cretaceous to Eocene block faulting and development of a southeasterly dipping shelf. During the second phase in Oligocene time, uplift and erosion occurred north of the basement faults, and many basement faults were reactivated and many basement control structures were formed. In eastern Manipur, thin Cretaceous limestones to the south are the oldest rocks reported near the Assam Geologic Province. The Assam Geologic Province consists of oldest sedimentary rocks. It is comprised of continental to lagoon sandstones and interbedded shales of upper Cretaceous to Paleocene, Dergao and Disang formations. The top of the Dergao and Disang, overlain by the medium grain massive sandstone of the Paleocene and Eocene Jayantia group, then Tura and Langpar formations, and is also marked by an unconformity. In a fluvial to marginal marine environment, more than 250 meters of the Tura and Langpar were deposited. The Eocene Silate formation was deposited in a range of environments and was subdivided into the members of different depositional environments. The lower Lakadang member was deposited in a lagoonal environment, consists of more than 350 meters of thin sandstone, and the interbedded shale and coal in its basal part. The members of the upper part of the Lakadang formation are calcareous sandstone of a restricted shallow water platform. The overlying Narpu member consists of claystones and siltstones of a shelf environment. The upper member of the Silate, the prang member, is a shelf carbonate with interbedded siltstones and clay. Due to contemporaneous platform tilting and basement source block faulting, the Silate formation is depositionally thicker from northwest to southeast in the Assam Geologic Province. The figure shows a diagrammatic expression of the Himalayan, northwest Himalaya and the Assam shelf, and we can see that there is a increase in the thickness towards the southeast from the northwest part of the shelf. Now, if we discuss the petroleum geology of the basin, then the source rock, that is basically is a composite petroleum system, that what we talk about, that is the Silate, Kopili, Beryl, Tipom, for the total assessment purpose of the petroleum system. For correlations of source to reservoir where hydrocarbons were available to the time of assessment, a composite total petroleum system that is used. The total petroleum system of Silate, Kopili, Beryl, Tipom are composed of the rocks of Eocene, Oligocene and Jayantia group, Silate and Kopili formations, the Oligocene Beryl group and the Oligocene Miocene Surma and Tipom groups. In Assam Geologic Province, the reservoir rocks are represented throughout the stratigraphic section. Reservoir rock consists of Eocene, Oligocene, Jayantia group, Silate formation limestone and Kopili formation interbedded sandstone. Tura and Langpar marine sandstone also have reservoir potential, and Surma group alluvial sandstone reservoirs are productive in the southwestern part of the Assam Geologic Province. The Beryl, marine pay sands and the Turam group massive sandstones are the most productive reservoirs. Permeability ranges from less than 8 millidarcies to as many as 800 millidarcies in the Tipom group sandstone, with porosities ranging from less than 7% to 30%. Now, coming on to the migration, that in the basin, we can say that below the Naga thrust fault, the generation of oil begins by the early to middle Miocene for the Silate and Kopili formation. The onset of generation is about 1750 million years ago for Langpar and Lakadong members of the Silate,
and today the generation is continuing in the deeper portion of the Assam geologic province. Primarily the migration is up deep along the northeast trending slope of the Assam shelf. Seals and trap, that is the primary trap of the area, are the anticlines and the faulted anticline structure subparallel to and associated with the northeast trending Naga thrust fault. Below the Naga thrust sheet, probably the sub thrust traps are present. There have also been stratigraphic trap discoveries such as the Dholia gas field, described as Oligocene barrel clastic depositional lenses, and Habjan and Sarojini oil fields identified as barrel depositional sandstone lenses. The seals of the areas are the interbedded Oligocene and Miocene shales and clays, and the thick clays of the Pliocene Gurjan group. In the southwestern part of the Assam geologic province, the upper marine shale at the top of the Tripom sandstone is a regional seal that extends into and throughout much of the Bangladesh. Now we discuss about the Bengal Basin. The Bengal Basin is situated toward northeastern part of Indian peninsula in the state of West Bengal. It lies between 25 degree and 25 degree 30 minute and longitude 87 degree 30 minute to 90 degree 30 minute and falls in West Bengal of India. It occupies an area of 89,000 square kilometer in total, in which about 57,000 square kilometer is on land and 32,000 square kilometer is offshore, up to 200 meter bathymetry. And that basically is considered that the prognostic for the hydrocarbon exploration program, where the prognosticated hydrocarbon resource in the Bengal Basin is placed at about 190 MMT of oil and gas equivalent. Geologically young and tectonically active this basin is, and which is traversed by Ganges, Brahmaputra, Meghna river system. The Bengal Basin is bordered on the west by the Indian Shield, on the north by the Shillong Shield, and on the east by the Naga Lusai orogenic belt, and is open to the Bay of Bengal at the south. The major tectonic features of the basin are shown in the figure that is given, where you see the hinge zone and the basin marginal zone, and so it is a typical kind of basin where you have the highs and lows. The formation of the Bengal Basin was initiated during Middle Upper Cretaceous time with differential subsidence. The episode corresponds to the deposition of subaerial fluvial clastics of Bolpur Formation. The rock beds of Bengal Basin are grouped into the Neogene and Paleogene rock units. The Neogene are composed of clastic sediment derived from the Himalaya, the Shillong Plateau, and the Arakan Yoma mountain ranges, and they are exposed mainly in hilly regions of Chittagong, hill tracts, Sylhet and Mymensingh. The Neogene sequence consists of unfossiliferous alternating sandstone and shale deposited in a lower succession and massive pebbly sandstone to clay in its upper part. The Paleogene sequence is exposed mainly on northern part of the Sylhet district and composed of alternating sandstone, siltstone and shale at its upper part, and limestone and sandstone is the lower part. When we look into the petroleum geology part of the basin, the source rock, what is found by the drilling in the shelf, slope and basin area, that shows the Oligocene and Eocene carbonaceous marine shales at the basic source rock. The lower Gondwana sediments contain about 44% of organic carbon with type 2 and type 3 kerogen. In wells like Golsi 1, Maninagar 1, Palasi 1, in this has been found. The vitrinite reflectance value of source material within the Gondwana sequence range from 0.47% and 3.29%. As we already discussed, that if I have the vitrinite reflectance more than 2%, that is considered to be inert. So the vitrinite reflectance more than 2% is not of much value, but definitely the vitrinite reflectance less than 2%, they are of consideration. Now reservoir rock, that is the in the Bengal Basin, they are early to middle Miocene sandstone and siltstones in the Surma and Stipam groups. That is Surma reservoir rock, they are chiefly tertiary age sandstone of the Bokabil and Bhuvan formation. Porosity, that is range from 10 to 20%. Reservoir sands range from thick channel fill and littoral or marine barred deposits to sandstones thinly interlaminated with shale and siltstone. Structural and combination traps of Miocene age occur along stratigraphic boundaries. The short distance and long distance migration that is predicted in the Bengal Basin. Seals at the Miopliocene shale sequences, they are act as an effective cap rock and seal in this basin. Interformational shales and clay stones of the Surma group are common seal for the gas fields of Bengal Basin. The Kopili shale may act as a regional seal over the shelf slope area. Now, we also discuss another basin, that is the Kaveri Basin. The basin extends along east coast of India, bounded between 8 degree to 12.5 degree north latitude and 78 degree to 80 degree east longitude. The hydrocarbon exploration it is happening from the late 50s. The first deep well were drilled in 1964. The on-land extent of the Kaveri Basin is 25,000 square kilometer and shallow offshore area comprises of 30,000 square kilometer. In addition, there is about 95,000 square kilometer of deep water offshore area. Kaveri Basin is a pericratonic rift basin and comes under the category 1 that we have already discussed, that what is the category 1. The map of the Kaveri Basin that shows that it is a horst graben kind of structure and that is oblique to the north-south trending coastline of the shelf. The boundary between Krishna Godavari and the Kaveri Basin is physically defined by sharp bend of eastern seaboard from northeast southwest to north-south, although the eastern Ghat tectonic trend influenced the structural fabric of the southern basin along the north-south orientation of the coastal plain. Both the normal topographic map as well as the structural map that clearly shows that the horst and graben character by the contour pattern of the Kaveri, what we can see. Coming on to the petroleum geology of the basin, what we can see, the source rock of the Kaveri Basin, that is identified detailed geochemical study conclusively established that the tertiary sediments are inadequately matured for hydrocarbon generation. Only the syn-rift and the post-rift Cretaceous shale sequences are mature source rock. It is important to note that adequate source rocks occur within and in the vicinity of the medium ranged corridor. The occurrence of the mature source rocks within the ranged corridor indicates a locally enhanced geothermal gradient that favored the maturation. The source rock typically is a mixture of type 2 and 3 type. Reservoir rocks in the basin is the extensive sandstone deposition that took place in the all grabens and half grabens during syn-rift phase of the Kaveri Basin that acts as reservoir. Also, the carbonates, siltstone deposits locally also from the reservoir. In the Kaveri Basin, fractured gneissic basement in the reservoir, indicating basement as a also a potential target. And the known reservoir areas are the middle Cretaceous Bhuvnagiri sandstone, upper Cretaceous Nannilam sandstone, Kamlapuram sands of Paleocene age. The syn-rift sequences of the Andimadam formation are still not well understood in terms of the source and reservoir formation. When we talk about the migration in the basin, what we see that the most of the sandstone sequences in the basin, they serve as good reservoir and that hydrocarbons are potentially accumulated within them. Both structural and stratigraphic traps were in place, and in some places faults also acted as a good conduit for fluid migration. The model considers that the effect of both open and closed faults for the hydrocarbon migration which took place during different time steps of basin evolution. The stratigraphic and structural traps present within the basin that help in the deep scale exploration in the basin. Stratigraphic traps including the pinch outs, wedge out, lenticular sand bodies are clearly seen in the early or to late Cretaceous sequences. Then regarding the seal and trap in the basin, it is a good seal that is in place in the basin with shale sequence of Cenomanian, Santonian and Maastrichtian being the major regional seal. The common hydrocarbon traps are structural, stratigraphic and combination, fault related structures and draped over basement highs helped in the hydrocarbon accumulation. deep water exploration in offshore Kaveri is till date not very successful, as it is successful in the KG basin.
So, students, we have discussed in this module that what is the total area of India that is covered by sedimentary basin, and we have seen it is about 3.14 million square kilometer area that is covered by the sedimentary basins, and about 26 major sedimentary basins that we get in India, which has been categorized as category 1, category 2, category 3 and category 4 basins. Category 1 basins, some of the category 1 basins such as Assam Shelf, that has been discussed, and we have seen that these basins have a good source rock potential as the reservoir potential. We have also seen that some of these basins, they have already yielding the large scale hydrocarbon, and they are identified as the category 1 basin. We get products of all sorts of environment in these different kinds of basins, right from the continental to the marine. So, we get products of different environments ranging from continental to marine in these basins, and because of that some of these basins, they are extremely good as a hydrocarbon reserve basins. In Assam Basin, since the discovery of the Digboy oil field, there are a large number of oil fields that has been described, that is Naharkatia, Moran, and still for a long time it is a producing basin. We know these basins, what we have already identified and explored and studied, that gave knowledge to us, which prompt us to study the further other basins. So, this idea of the basins, that some of the basins they have very prospective, some of the basins they have the character to be prospective, some of the basins they are not yet fully studied, but needs to be studied. All these things that makes the study of sedimentary basin is a very topical issue, that what are the major basins and how far we have advanced in the study of these basins. I believe this discussion will encourage you to study about the Indian basins more and more, and also encourage you to go for the study of these basins in future, so that the more prospective basins can be identified and they should be explored in detail. With this I end this module. I believe that you have enjoyed my discussion about these sedimentary basins of India, and you will go through the further literature that is referred to the e-text and go for the further studies. Thank you.